Hello everyone, welcome to a new episode of Lukas fragt. As you can see, there's some changes today. I'm about to speak the whole episode in English because we are in the land of the free. We are in the United States, here in Meadville, Pennsylvania. I'm about to speak to Blair Learn, who runs the company with his three sons, Chris, Dave and Mike. We're gonna have some nice shots of laser welding and all the other applications. I'm gonna interview him. I'm very curious about it. So I think let's start.
How are you doing?
I'm doing fine. What about you? Thank you for having us.
Good.
Here, as I promised outside, we're about to interview Mr. Learn. He will show us the factory.
Welcome to Phoenix. So this is a new part of Phoenix where we do some automation, where we have customers that need to do the production themselves of the welding. So we develop automated systems for them to purchase and move in-house, and we train them and support, and then they can do the welding themselves.
Awesome. Okay. So is this where you started and you added this whole additionally, or
Yeah,
what?
When we were in 2008, we built this building here to that wall, and then in 2014 we added on once, and then 2019 again, and 2022.
Okay.
So it just keeps adding on. Then we do some development welds over here.
This is an assembly.
That's another system that we're building for ourselves, just to do, production laser welding in-house to make us more competitive.
So this looks a little bit like a service department, or what is?
Yeah, these are some machines that we're just waiting for parts to reproduce or update, get them back up and running as they should.
Seems pretty familiar to me, these ones.
Yeah, Alflac Max.
Can you give us a little overview how it all started with Phoenix Laser Solutions?
Yes.
When were you established, and a little bit about the history?
So about 2/10 of a mile from here, I had another shop where we designed and built plastic injection molds. So 35 years ago, we purchased a laser welder to bring in-house so we could understand that technology. And in 2006, there was a fire there, and we moved into here 2008 because my oldest son at that time was running the laser department inside that mold building company. So I was trying to just get him back up in business. And so we had 3 laser welders and a laser engraver and in that building. And then we outgrew it and just keeps going. So, now Phoenix Laser is, one of the largest repair laser welding houses in North America. So we've got 35 lasers.
Awesome. Wow.
So we have five shops: Pennsylvania, Ohio, Indiana, Michigan, and Missouri. So all of them, just because people don't have the time to ship parts, so if they can get close and drop them off, pick them up the same day or sooner.
So you are able, if somebody knocks on the door, has a defective part, and you are able to fix it, and give it him right back.
Yep,
Really?
Routinely we do that. Well, people come here, they may drive 2 hours, drop a part off, wait in the parking lot,
Okay.
and we'll knock on the window, hey, your part's done, and drive back
great.
home.
That's awesome.
Because everything's an emergency. Not everything, but a lot of the stuff, if they can get back up in production, it makes them money. So
Yeah,
it's very important. So this is where we weld, tooling, like heat-treated alloys that have been damaged or broken, and we'll laser weld them with the appropriate alloy so they get another life cycle. So that asset is they continue their return on investment for the original asset.
Okay. As far as I can see here, this is a yak laser. Is this only yak lasers inside this hall?
Yeah, this is how we originally started, mostly with YAGs, and YAGs are very good machines for welding tool and die parts. So we started with YAGs, so we're continuing with the YAGs in this department, and it's plenty of power for tool and die welding. The welds are usually small in nature, and these machines are very fast. So we go up to 500 watt. Those 3 or 500 watt machines. These two are 300 watt machines.
Yeah.
So it's a great tool for what we're doing in this department.
Sure. So when you say you started with yaks, I assume you also have fibers then?
Yeah, we have fibers in the other departments.
Yeah, we will see later.
We'll see them.
Okay.
But this is the tooling that came in today,
Okay.
that we have to weld and get repaired to go out. It changes every day. So tomorrow, these guys have to be very diverse, that they can go from a round part to a flat part, and from one alloy to another alloy. So those cabinets out there have all of our welding wires. So we might have a couple $100,000 in different alloys of welding wires in-house, so that we can weld it with the best solution for that application.
Gotcha. Okay. So the job is never getting boring then, because the tasks always differ.
In this department, it's different every day.
Okay, cool.
Yep.
Talking about laser welding, what is for you the biggest advantage about laser welding in general? Like, compared for instance, to TIG welding or?
Yeah, so the benefits of laser over conventional welding is the control of the heat. So everything these guys are welding in here, you can hear it from their pulse lasers. So you can put your hand on it. The parts are cold.
Really?
So we don't change the color. We have a very shallow heat affected zone. We're putting a material that's equal to or better than the original base material. It's so they get an equal life cycle on the repair as they got from a brand new part, or an improved life cycle, because we can change materials a little bit. So
is this something when customers come to you, they are looking for example, like that you make the piece, they, for example, mold, when you bring it, that you make this, when you repair it, make it last longer than it used to be?
Well, yeah, that's something that our experience affords us to offer them. So if this was a stainless part, but the bearings are wearing out, so we would put a hardened material where the bearing is and leave the rest stainless, so that they get that part never wears out again. So, at that bearing area. So we can change materials, and because we're tool and die makers, we understand the benefits or the weaknesses of changing the materials.
Gotcha. So you not only have to be a good welder, you also have to be a metallurgist. How is it called? Sorry.
A metallurgist?
Metallurgist, sorry.
Yeah, so we've learned a lot about metallurgy since we started welding with lasers, because it's a big part of the application. If you know the metallurgy and what hardness the part was originally, you could pick the appropriate material to put on it to give them the best solution moving forward. Here we're taking a component for a customer, we're laser hardening it, and it's the same, that big black machine in the other room.
Gotcha.
We've been welding these, or laser hardening these parts for a few years for this customer, and then they said, hey, we're thinking about bringing that in-house. So that's the solution in the other room, that we're selling that machine to them, and they'll do this in-house. So we're heat treating their components so they last longer, versus an induction or a flame heat treat. They don't want the whole part hard. They just want the two
Parts
surfaces.
of it.
There's a jaw surface and a cam angle that puts the pressure on the jaws. Those two surfaces need to be hard, but everything else, it's better that it's a little bit more ductile.
That it does not break, right?
Yes.
When pressure's
too stiff
coming.
and
Yeah, gotcha.
And then they'd have warranty issues because they're breaking too soon or
Gotcha.
by misuse.
Since you started with laser welding, when was the time you decided to go for laser hardening as well? Or how was it?
Yeah, so Alpha Laser keeps, growing and creating new technologies. And then, so every time they do that, we try to explore them and see if it's something we could bring in-house to offer that same service to our customers. And, so this has probably been 5 years now. We've been laser hardening here at Phoenix. And, we had that for 3 years and we bought the second one. And then we also have one in Michigan. So we've got 3 of these systems inside Phoenix Laser's suite of companies now. So we service multiple industries.
It turned out to be a good idea.
Yeah, it's good business.
Okay, here we have
So this one is doing
basically
cladding,
the same setup.
except this one's doing powder cladding. That one's just
Okay.
doing heat treat. Just
Okay.
by changing the heads, we can go from powder cladding to just heat treat with the same machine and the same operators. So
Okay.
this department here is medical. It's our precision laser welding department. So it's mostly welding medical components.
Needs to be a little bit close from the outside, or what's the reason why it's like in a cabin?
Cleaner, needs to be more process driven, because it's a locked process. Because usually we're doing full penetration welds in here, so we have.
What's that mean, full penetration?
So if you're putting 2 parts together, they want it to be as strong at the joint as it is everywhere else.
Okay.
So we got penetration through the whole thickness of the part. So it's full penetration welds. It can't leak. So we have a helium leak tester in that room to test the components when we're done. It's just another aspect. But in that room we use fibers. So
Okay.
these are fiber lasers because we're using CW, continuous wave, instead of pulse.
You mentioned analyzing right now here. Is when a customer comes with a problem, let's say he has a problem, and you do not have the figured out how to proceed or to help him with his problems yet, how does this work? Like, do you have some kind of analytics or analyzing equipment?
Yeah, so upstairs in the first building, there's a pretty complete metallurgical lab. So we always cross-section parts, mount, polish them, look at the micro hardness, the grain, the heat affected zone. We thoroughly look at the weld characteristics and we share them with the customers and get their input. And if they want changes, like yesterday we had a customer here most of the day and we welded several parts and we fine-tuned the weld while he was here and we locked down the procedure and the process. So now we have good work procedures moving forward. So when those parts come in, he's going to get exactly what he wanted and needs. And usually it doesn't happen that way. That it may take 3 or 4 back and forth, then we send him the reports. But he was here, so he got to see it from start to finish. Made him a lot more comfortable with our process and that our control of the process, and that he can walk out knowing that if he sends parts in, he's going to get them back a certain way with certain results. So in 2019, we went back into manufacturing. So all this equipment is new since 2019. So we do manufacture and machine parts. Our goal is to machine parts that need to be laser welded together. That's a long process, but while we're getting there, we do some just machining only projects also. This department here is our heavy high wattage laser or fiber lasers. So where we're putting a lot more material on, faster, working on bigger parts. So there's sitting inside a part that weighs 4,000 pounds and.
So we saw those YAG lasers. Now we have here the fiber lasers.
Yep.
Is there, or can you say something about the difference or when you use that and when you use the other technology? Is there something you can say about it?
Yeah, they're the fibers are newer. The YAGs were first. what kind of welding that we're doing, pulse laser, really controlling your heat. And the fibers came along, and they have some benefits for longevity that the YAGs don't have, and for maintenance. But they also yield you a lot more power. So we can go faster. We can execute welds that we couldn't execute with the YAG, just because it would take too long. But they both have their place. We found with the new alpha lasers, the fibers they're workhorses. We can get a lot more work done with the fiber for this type of work. You wouldn't. I'm not saying you couldn't use that welder to do what we do in the precision tooling area, but we already had those, so we use those. But because these are here, we use them where they're the perfect solution for these jobs. But those machines, you would be too expensive with the YAG to do this.
Okay. Do you train your welders both machines, or is it not quite that a different job? You know what I mean? Like
No. My welders are cross-trained, so they can run both.
Okay.
There's guys that are just, they've got more experience on heat-treated alloys. That's something they have that these guys don't need, because most of these alloys aren't heat-treated. They're a high-temperature alloy or power generation. They're just different characteristics that these guys know that those guys might not know as well. But either one of them could weld.
I assume they are helping each other. If somebody has a question, like what parameters do you use, or can we change something? They're helping out each other, right?
Yep.
By the way, I didn't ask how many employees you have here or all around the US.
At this facility, there's like 70 or 75 employees. All together, there's a couple hundred employees total. There's a molding company that has 70 people, and then the other 4 shops that have, they range from 4 to 8 people in each shop. So it's enough. Yeah. So here we can do, the 5-axis. We can machine this part, totally. It's got holes through the outside, going perpendicular to the other features. We do some castings. Here you'll see some pretty extensive tooling that got damaged and it comes in for repair. So to remake that part, it would be,
This is waiting here for those guys, right?
Yep, for some welding.
Okay.
And that could take 16 weeks to rebuild it if you had to make it over. So here in a week you'll be back in production.
You do some testing on them then, or
So we do inspection.
okay.
And we don't assemble them, the customer assembles them. So this part bolts onto that rectangle area sideways.
Yeah. Do you check every single one, or is it like you pick 1 out of 10?
We do in-process inspection and we do final inspection. So just to make sure our systems are in process. Yeah, so these in the blue bags, those are finished.
About to send out.
Yeah, all of these are finished. So they're heat treated and they're turned hard, and we're holding 4/10 tolerance on the OD. So they're very accurate. And we have our inspection department. We've got a camera system over there and a probe there, for automated inspection.
Okay. Wow. What do we have here?
So this is a turbine that we're making. So this has been roughed out and then it went to stress relieve, and then now it's coming back to be finished machine. So we relieved all the metal, let it move, and then we stress relieved it, and we'll finish machine it now. That's the old guy that runs that manual department. He's sawing some hardened parts, so we're gonna take test specimens out of these parts to check the hardness.
You keep them? The testing?
Well, they're going to do a wear test on them to see how long that alloy will yield them Those are big cams for a locomotive. Well, this is storage. This is the water jet, which he must be off
that
today.
means you
We cut with water.
cut with
Yeah.
water. Yeah.
So, like he can take this big block and cut it with water right
Like
through.
this.
Yeah, they can go 6 inches thick.
Look at this. How does it work? You cut underwater? No.
No, you got a jet that comes out of here
Yeah.
and it pierces through the part and moves. And then
But is the part underwater?
no, it's just it's on top. You can submerge it
Okay.
because sometimes they get hot because of the friction.
You have so much welding and hardening. Why or what is this jet machining meant for? Why do you use water to cut?
Because the water jet doesn't put any heat into the part. So we're going to check the welds on these. These are fan blades. So we can cut them with the water jet and not change the metallurgy. So if we were to use a conventional method like a cutoff saw, it'd be a big cutoff saw. It would affect the metallurgy. Water jet won't. So it's just a good tool for. We do so much cross sectioning of our welds that the water jet is great to have. It's a very valuable tool for us to get our samples. Well, everybody says, why don't you have a laser? Well, laser has heat,
Right.
and it's uncontrolled, so it's not as good as a tool, and we don't make millions of parts, so that's half the money of a laser, but it's cold, so it's perfect for us.
So what do we have here? Not the parts, but the department we have here is.
So this is where all the work goes out back to the customer. So this is shipping, where we take pictures of the parts when they come in, and we take pictures when we ship them out, so that if they get damaged, they know it didn't happen here, or it did happen here, which we hate. But these are finished parts; they're going back to the customer. So, wow. So this is the Met Lab, where we do some cutting to bust down the specimen to a part that's small enough that we can mount it. So then we mount it with these machines into a puck. So we'll get a puck with the part.
That's the puck. Yeah, puck.
This is a puck.
Like ice hockey.
Yeah. So now we can polish it and get a mirror finish and look at the grain structure and the heat affected zone. And on other equipment over here, microscopes and micro hardness checker. So it just all this equipment is just to get it to this. And this may be out of a part that's huge, but we have to bust it down into this segment. This small specimen.
Does it often happen that customers need this or want this? That you do an analysis like that?
You see how many machines there are, so it's running every day.
Okay.
That most of our customers, like the tool and die customers, generally don't have that knowledge that they need this. So we still do it, but they don't understand. Most of them don't understand, so we just do it to make sure that we know it's right. But the other customers, like power generation and medical, they all demand it. You would never get a job if you didn't have this.
Okay, so they certify it somehow then.
Yeah.
Okay.
This is a sample where it's very visible to see the weld, and you can see the heat affected zone in a dark zone right underneath the weld onto the base material. So, this is what they're looking for. So if we can, this is very visible where the weld is. So that's this sample is it explains it better than my mouth.
So what does the heat? How did you call it? The heat?
The heat affected zone.
Yeah.
So
what does it say about the welding?
it shows how deep the weld changed the metallurgy and how soft it got. So usually the heat affected zone softens the base material. So you don't want that to be very deep. Like, so conventional weld will drive heat in so far that maybe 100 thousandths deep is your heat affected zone, and you soften it 15 to 22 points. Where when we use a laser, our heat affected zone is very shallow. So we may soften it 2 to maybe 8 points in the heat affected zone, but very shallow. So maybe only 4 thousandths deep. This one is a fiber laser with a big weld. So our heat affected zone is a little deeper, but still a lot less than conventional welding.
Okay. For example, if the heat affected zone would be more, what does it to the welding, to the welding seam? Is it breaking out, or is it like only affecting the base material that it's not that?
It's softer. So what it does is it makes a very weak root system. So when they start putting pressure on the weld and it's soft underneath, the weld's hard and the base material's hard, but the zone in between is softer. So now every time it flexes, that becomes cyclical shock. So it flexes so many times, and it might take 1,000,000 times, but it's going to crack. And it's going to crack in that heat affected zone.
Okay.
So it's just, you got different characteristics now, and the weakest one is where the defect will be.
Perfect explanation. Thank you.
Yep.
Didn't know that.
Well, thank you guys for coming to Phoenix. I hope you enjoyed the little tour, and I hope you learned some things about,
of course,
how we're using Alpha's equipment.
Thank you so much.
Oh, thank you.
We see here, we visit you at Phoenix Laser Solutions, but there are 2 more companies here. Can you explain us a little bit what is that about?
So Phoenix Laser is what we started as, and then Alpha Laser and us joined forces, and we sell the Alpha lasers in North America, for Germany, and we use the Alpha Laser products. You saw them throughout the shop. And then when we started, when Alpha asked us if we had any interest in laser hardening, we bought the rock, and we're not heat treaters, so we learned a lot about metallurgy, but heat treating is a whole nother science. So we joined forces with Peters Heat Treat, which is like 1/10 of a mile down the road, and they've got the knowledge of heat treating. So we needed that to be a good provider to our customers. So Laser Hard is a joint venture between Phoenix Laser and Peters Heat Treat. So everything that you saw in there is owned by the Learn family, except for Laser Hard. That's between Peters Heat Treat's family and the Learn family. So Phoenix Laser is me and my 3 boys, and David, my oldest son, runs the office group and the accounting, and Michael runs the welding department, and Christopher is doing the high-tech laser welding for all of the big customers, the sales and the testing and the support for those guys, so that they know they're getting what they want from our welding group.
Awesome. Thank you so much.